going. Okay. So yesterday we briefly started talking about this, and then I realized we did not have enough time to even remotely get through it. So I just gave up and gave you some free time yesterday. But when we did start, I did have you hopefully add this up here. So originally I had just titled this gradient, but these are going to be the steps for calculating gradient. We established yesterday that gradient is a fancy word for slope or how steep a hill is. So before, we were able to tell which side of a hill, let me find a good one. For example, on this one, you could tell me which side was steepest before, right? Which side's steepest? The,
Right.
oh, we're having some controversy.
Sorry, no, yeah, right.
Okay, side B, which is the right side for those of you who are saying left and right. By the way, is that the north, south, east, or west side of the hill?
Wow. No. East.
So never eat soggy worms. Whatever. That's how they're going to ask you guys that for the record. They're never going to want to know the left side or the right side. When they ask this question on the regions or any test I give you, they're always going to want the compass direction. So just stop saying left and right and say north, south, east, or west. So that is of this hill. That's over on this side. So that's the east side. By the way, how did you know the east side was the steepest? Because the lines are close together. So you do need to know the basics. So you need to be able to tell me which side's steeper, which side's more gentle. But then the Regents is going to take it a step further and they're going to say, well, how steep is it? And you got to be able to tell me in a measurement how steep the hill is. It's now often in real life, we would measure this in an angle. So you might have heard like some roads are like a 40-degree grade. Get it? Gradient, grade. But we aren't going to be using degrees. We're going to be using elevation divided by distance. And so either feet per mile or meters per kilometer to do this. So when I say the word calculate, what do you guys automatically start thinking about? Math. And in this class, you do not have to, two things. First of all, don't do math in your head. Even adding, subtracting, multiplying, dividing, even if they're easy numbers, I would like you to use your calculators because it's typically the easy numbers that you guys get wrong, like telling me 2 times 2 times 2 is 6. Yes. Kind of. Give me 40 minutes. Okay. Thanks. So where was I? So just like the when we were doing length times width times height, and you guys were telling me 2 times 2 times 2 is 6. It's the easy math that people get wrong. So please don't do math in your head. 2 times 2 times 2 is 8. So I did put up there to use to get a calculator. I'm not going to have you guys use your phones today because we're going to be using them over and over again. So I don't want them out and distracting you throughout the period. I would like you to use a regular calculator today. So if you need one, I always have them up there, or you can use your own. I don't care. But anyway, what else you don't need to do in this class is memorize math formulas. So in math, you have to memorize them, I think, but in this class, we don't. Every formula you ever use, except for average, is right in your reference table under equations. So we're going to be doing gradient today, which you can see from your reference table. Gradient equals the change in field value divided by distance. Do you know what I mean by change in field value? Kind of. What part do you get? The change part. Yeah, and probably the value part, I'm guessing. Now, field value is just a change in whatever's being measured. So if it's a map of elevation, it's going to be the change in elevation. If it's a map, I don't think I put any others in here, but if it's a temperature map, it'll be the change in temperature. If it's a pressure map, it'll be the change in pressure. So it's a change of whatever the heck the map's talking about. So that aches and pains one that I showed you at the beginning would be a change in the level of aches and pains. So it's just a change in whatever the heck we're measuring. Now I know there are people here who are good in math. There are people here who wish math was never a thing, and everybody in between. So I kind of take teaching anything about math, I teach from the lowest level. So what I mean is I do the most basic steps. I kind of spell out word for word. So some of you, especially if you're a decent in math, you're going to be wondering why this concept is taking so long to teach. I would like you guys just to work with me today, and then I'll show you the shortcuts you can take after we go through this. So I've broken calculating gradient down into 5 steps. So that being said, for some reason I have 6 boxes here. Can you go ahead and cross off the bottom box? I don't know what, I must have just hit enter again and didn't mean to. Never been 6 steps, it's always been 5. And basically these steps are going to walk you through how to use this formula. In fact, do you guys have some room up here? Let's write the formula up there. So gradient, I'm just going to abbreviate gradient with a G. Gradient equals change in field value divided by distance. You'll often just hear me say change divided by distance. I get rid of the field value part because it's, again, just a change in whatever the heck you're measuring. So that's there. These 5 steps are, again, just walking you through how to use that formula. So for some of you, you're already done. And the rest of us were struggling a little. I was in the struggle a little part. So I have these really simple steps. So you ready for step 1? Step 1, again, you're going to be given a map. It could be any one of these maps we could calculate gradient on. So it could be this one that we used the profile for. The first step is, and this might sound familiar, determine the contour interval and write it in for each line. That's step 1. Does that first step sound familiar to anyone? What? Why? It's literally step 1 of how to do a profile. So before you can start doing any math, you need to know what those lines are equal to. Like if you don't know what A is on, so for example, I think all of these it told you, but if you didn't know what this line was, you need to add the numbers in so that you know. So it's just labeling the lines. That's it. Not overly difficult. The good news is if they made you do a profile, probably the next question is calculate the gradient. So we've already done this. You don't have to do it again. All right, that's step 1, super easy. Step 2, we're going to be finding the change. Find the change in the field value. In other words, calculate the difference between the 2 points. Ooh, calculate the difference. What kind of math are we doing to calculate the difference? Okay, so if you want to add that, you might want to. So I said calculate the difference, parentheses, subtract between the 2 points. So we are finding the change in field value, and to do that, we're calculating the difference between the 2 points. We're subtracting the 2 numbers. This is always going to be a positive number for this class. If you were being really official, a negative would mean you were going downhill. A positive would mean you're going uphill. we're not being official. Just always make this a positive number. So the bigger number minus the smaller number. Step 3. Measure the distance. Between the 2 points. So measure the distance between the 2 points. How do we measure distance between 2 points on one of these maps? And the map scale. So use scrap paper and map scale. Now for my step 4, this is the part that some of you might do now. Some of you might have done it at the beginning. Step 4, I just have you write the formula. Write the gradient formula. So I am going to rewrite it. Step 5, nice and easy. Solve it. I do want to point out change in field value. What step is that? Which one calculated the change in field value? So this is really just taking step 2 and dividing it by which one did we find the distance in? Yep. So you're really just taking step 2 and dividing it by step 3. Not overly complicated, I don't think. Keep those handy. You might want to even open them up so you can see both at the same time. I have one thing to point out on this before we go through the steps. The dot for A is right there on that labeled 100. And by the way, that says 100 if you can't see it, if it didn't print very nicely for you. But B is not on that 250 line. The dot for B is just below the letter B. It's on the line before 250. So let's walk through the steps together this time, and then I'll let you guys try this on your own. And then you have just a short 10-question homework assignment. So let's reread step 1. Determine the contour interval and write it in for each line. So in this case, I labeled the 100 and labeled the 250. What are the lines going up by and what should we label them? Do you already figure it out? They are going up by 50s. Again, just try some numbers. So 100, 150, 200, and then 250 is already labeled. Is there any work to show for step 1 down here? No, there's no work to show. So I just put an X there. There's nothing to show. Step 2 from our notes. Step 2 says find the change in field value. In other words, calculate the difference or subtract the 2 points. So again, I'm just going to do this all the steps, and you don't have to do this once you've got it under your belt. But for today, let's say, what is the elevation at A? 100. And what is the elevation at B? 200. Ooh, what are these labeled in, by the way? Because there cannot be any naked numbers running around. These are not in miles. They're not in meters. Nope. Feet. So here's a couple things. So this is really useful information. So first of all, what are these lines telling us? 200 is supposed to be how high the mountain is. Mount Everest, which by the way is the tallest mountain on the earth, it is about 5.5 miles high. 250 would never be a miles. That doesn't exist. Now, how did you guys, I'm guessing said miles because this is in miles. Remember, this measures distance across the map, like how far apart they are. So this is in miles, then these lines are going to be in feet. So miles and feet go together. Just like if this is in kilometers, this will be in meters. I will say that most examples will tell you, like here in this one that is going to be one of your homework assignments eventually, it does tell you elevations are in meters. This one labeled it down here in meters. This one did not tell you. So this was a case of it's in miles, so you need to know those go by feet. Miles and feet go together, just like in the United States, we use feet and miles, but in Canada, they use meters and kilometers. But anyway, back to this. So that's A is 100 feet, B is 200 feet. What do I do to find the change? Subtract. So 200 minus 100. Again, I think you can probably handle that one without a calculator, but you could use a calculator, no judging. And notice I labeled it feet. I'm going to also just label this step change so that I remember that. Step 3 says measure the distance between the 2 points. Use scrap paper and a map scale. Scrap paper. How do I use a scrap paper to find the distance between A and B? Okay, one I don't like when you use the ends. It causes an optical illusion. So when you're doing this now, you're not doing a profile now. So I don't care about this 150 line. Don't mark it. You don't need it. You only want to mark where A is, and I'm going to label it just in case my scrap paper has a bunch of stuff all over it already. I'm going to label A there and B there. I don't care about any of the other lines. This is not profiles. Now, what do I do now that they're marked? Go to the scale. And mine is just a smidgen past the 1. What should I do with that information? No. We don't just go to the nearest whole number or an easy to read decimal point either. You do have to estimate. So keep in mind, we're a little past the 1 mark. How many miles would you want to call that then? 1.1 works for me. So 1.1 miles. MI for miles, everybody. If you put an M, that's meters, and it's wrong. The Regents will not accept it, even if you do everything else correct.
So what people want on the region, so they say,
It maybe, I don't know. It would depend on how picky they're being. Normally they give a range. So normally I would say it would be fine, but they also might not accept 1 because it was clearly past the 1 a little. Like they might accept 1.1 or 1.2, but not 1 because it was clearly not 1. So by the way, this was the distance. I am going to label that just for this one time. You don't normally have to do that, but I want to have a good, clear example here for you. Step 4, again, was just to write the equation. You can shorten it up. I'm going to do change in FV, field value, divided by distance. And step 5 is just to solve. So my gradient, the change in field value, which step was change in field value? 2, so that's 100 feet. What step did we find the distance in? 3, so that's 1.1 miles, MI. Plug that sucker into your calculator and round to the nearest 1/10 of a centimeter. What'd you get?
9.
Okay, so might look like something like that, and I want it rounded to the tenths place. Which number is the tenths? 90.9. That, though, is a naked number. What are the units? Okay, so in case you're wondering where they came from, they're right there. And that's one reason I encourage you not to ever have naked numbers anywhere around, because now I can easily see I have feet over miles. So that means feet per mile. You can do it diagonal like that, or feet over miles works too. That means if you walk from A to B, your elevation will change 90.9 feet for every mile you walk. So that was a lot of work. A lot of you will find easier ways to solve the equation, and you're more than welcome to. So do you guys want me to show you how I mean to do it easier? Okay, so I'm going to use the same one because we've already done it. If you were to do this the way I think most of you probably can, because you're not new to math. If you struggle with math, do it this way. But if you don't, start by writing the formula. Gradient equals change in field value divided by distance. That's where I personally would start. I'd start with the equation. Then I can do the change in field value. I can see that I start at 100 and I go to 200. So I would write 200 minus 100. Divided by distance, you do all the distance. We already did it, 1.1. So this continues on to be 100 divided by 1.1, which equals 90.9. Again, feet per mile. So if you just want to do math like you guys have been doing math your whole life, go for it. But if you need it spelled out, do it the 6 or 5 steps. Either way gets you the same answer. It's just how long it takes you. One thing I can tell you is the Regents is not going to give you a half a sheet of paper to do the math. So that's also a thing. Think you got it, or do you want to do another one together? Try it. Try this very next one. So turn your page to 32. Try that one and make sure you have me either check it or wait till we go over it before you start the next one. How's that? So go ahead and give this question, calculate the gradient on page 32. I'll go over it in just a few moments. Anybody know you need my help already? I can check it, yep. Yep, but your unit is not. Yes. Yep. Not the bottom numbers. Right, no.
This one is right?
No, that's the contour. Actually, I don't know what that is.
It's 5.8. I just,
Oh, that's an 8. I'm sorry, I thought that was a 0.
no.
Nope, you're good.
Okay.
Mistake. And I didn't see the decimal either, so. It was all sorts of wrong in my brain. What do you got? Okay, so step 1 you did. So there's no work that shows except you cross it off. Or step, I'm sorry, I did step. We were right the first time. I'll be right there to help you. But it's the so right here, step 2. Defining a change in the field that you were calculating the difference between the track. So. I'll be right back. No. Yep, you're right. Yeah. Yep, but that's not the 10th place. You need to go do the.
Okay.
Here. And what you do, tell me what you were here.
I didn't know what you get.
You have the distance divided by the change.
Okay.
What? Grab paper and that together. Yeah. Don't forget. Yes. Yes. Yeah. Yeah, I remember that. What did you have? Yeah. This is also correct. It's different than for some ways. It's like I will talk about line. But if I say round, that's not. Yes. Because that is why this. And that's not how that. And I'm gonna talk. Yes. Yes, ma'am. Oh, that means we have a test. All right, oh, wait. Okay, let's go back to page 32. See how you did on page 32. I know a whole bunch of you have gone on, so if I've already said go on. Yeah, you can go on. No, wait and go over it with me. So everybody flip back to 32. Sorry, I'm being difficult. Step 1, determine the contour interval and write it in for each line. All you should have done for that is 22 blank 26. We're going up by 2s. This just needed a 24. Nothing to write in that box. Step 2, calculate the change. 26 minus 22 gives us a change of 4 feet. Here's where some discrepancy came in. I said they were 5.8 miles apart. What do you guys say? 5.7, fine. What else? 5.9, fine. I'd say as long as you were between 5.5 and 5.9. Like you didn't say 6, you didn't say 5.4. You realized it was halfway or more. Then you would have been fine. And then for these two, you plugged them in and then you hope. So remember, it's the change on top. So the 4 feet divided by the 5.8 would have given you, and rounded to the nearest tenth is 0.7 feet per mile. A lot of you have already gone on to this one. And again, the biggest difference is some of you are going to estimate step 3 slightly different. So as long as your answer is close to everybody else's, you're fine. But I do want to talk about rounding for 1 second. Guys, what does this number round to? Okay. This is rounded to the 10th place. Is this also rounded to the 10th place? Not. What is that line telling you? It's telling you it's doing this forever and ever and ever. So if you write that little line, you're telling me this. So this is not rounded. No little lines will ever pop up on an earth science test because they're always going to tell you to round something. So they will never have the little line. That implies it goes on forever. It's literally not rounded. All right. So for the rest of the period, you are going to finish. So you guys, some of you have already done this. 33. Oh, there's only 33 and 34. Once I give you my approval on those, you're going to start your homework, which is a separate packet. Let me just put this up here for a second. So this is going to take, it's going to give you a map, a beautiful contour map that's done beautifully for you already, and then ask you to draw to what are the intervals, what's the highest. Ooh, this is the only change I want. When you get this, this is the highest possible elevation. I'll remind you of that when I hand it out. So it's the highest possible elevation. So the highest elevation that could be on this map at all, not the highest one that's listed. And the only other weird thing is back here where I ask you to draw a profile. I did not label the lines on the side. You got to figure that out on your own as well. Just do anything that works. Hint, the contour interval works. So once I've approved yours, I'll bring you some homework. So that's it for the rest of the period. Oh, wait, okay. All right, so now that I think I checked everybody's, I just want to make sure that you guys all have the right answers. So here on page 32, we would have done 4 feet. I estimated that to be 5.6 miles. Some of you might have said 5.7 or 5.8. It will change your final answer down here, but I got around 0.7 feet per mile. So as long as you were within, I'd say between 5.5 and 5.9 for that one, your answer in the end will be perfectly fine. On page 33, again, depending on how you estimated step 3 here, I said 1.5, but I saw plenty of other people use different estimates here. Either way is fine. I got 6.7 feet per miles there. And on page 34, I got 2 feet per mile. And again, that was using 9.8 as my miles. So if you did something slightly different here, your answer might be slightly different there. All right, so that's it. Don't forget to do your homework, which I just showed a second ago. I don't know where my copy went. So this is the homework. Again, you're going to change this to the highest possible elevation. Everything else is correct in there.